So guys, I will show you in this video how to use OpenVSP to help you to make your command and to import this into Fusion 360. So here you have right now an idea of what you can get if you use OpenVSP. And the beauty of this is in OpenVSP you can move everything as you want. Any form, you can move the location of your command in X, in the Z, the thickness and whatever you want, changing the profile. And we import all of this in Fusion 360 in step or EGS file. But here I need to redo this because I have a little problem. Let me show you the problem. It's okay to draw some CAD file to make everything looking smooth for aerodynamical purpose. But look, what is the height here between here and here? So we have less 2 of 10 millimeters. So when I will go to the milling machine, do I have a bit of 2 of 10 millimeters? No way. In the milling I have a maximum thickness bit of 1 millimeters, which means that I have to redo my work because I was a bad guy and didn't pay enough attention on the trailing edge to have 1 millimeters. The wing, it will not have a trailing edge of 1 millimeters, but this will be bite surface here. This will be a flap-roll arrow, so it will move up and down, and this will be not a big deal. In OpenVSP, I need to redo, and I will show you how this is gonna to work. Let's have the real stuff about the command. The command looks in OpenVSP like this one. It looks like a little strange, isn't it? And the fuselage looks like this one. And now you start to understand this one is exactly like this one. They are the same. Here I have to close this one, the face, but it's not a big deal. So just to show you how it had been done, we use a stack body because OpenVSP allows us to choose a fuselage, a pod, or a wing, or an ellipsoid, or a human, a hinge. The beauty of the stack is that I can blend, make some curvature, I can manipulate this geometrically, mathematically, to get the shape I want. How it works to modify this. For example, if I want to modify the top side, which will mean the extruder, I can play with this. Okay, so you can see here right now how it's moving. You can change the curvature here. So this is something that I should use. If you are not happy with what you see, you can put your value here with the hand because maybe this linear tab is not enough. So we can see that this one is better than I did before. Maybe you can play with this one and you can play with the angle. Okay, so that was only for the extruder. And now let's play with the right side, which is more about the leading edge, very likely. So be careful with this because it's very powerful and you will distort the line and the volume to a point that it will make no sense and you will have a lot of problems. So be careful with this one, the left side, the right side, because let me play with the left side, which is here, the leading edge. So I have an angle here So you can see how it is powerful. It's moving very fast. So the slew, you can see what happened. And of course, maybe you didn't notice this, but the location is starting from a specific point. I mean that all of this stack object is referenced in the Y, X, and Z working space. And so I can change it by moving. But I have, and I must, of course, my root profile matching the root profile of the wing. This is, of course, 100% what you have to do. Just playing with this, you should achieve easily a wheel command that you like. Okay, we redo this so you can see the power of OpenVSP. And now I need to put this wing. Okay, so of course, as you can see, some strange things happened because I pushed the limit too far. So it seems to be that I have almost didn't change it, the entrado, but this is very hideous now. I need to come back and to select my stack, play a little bit so you can see the effect right now. Do whatever you like, do whatever you want. In OpenVSP, you don't have any undo or redo button. It's not like in many software, including Fusion 360. You don't have also a timeline like Fusion 360. So if you do something wrong and you cannot come back, you are done. Which means, for example, if you are modifying something here, the best is to remind minus 11.74. Or if you are making something bad and you don't know exactly, you just need to quit with discarding the changes and you reload the previous file. It's good, for example, to have many files. It helps me to have some history if the software is crashing, because it happens sometimes. I'm gonna to show you what is inside my stack. You will see that there are two sections, and guess what? One is a profile that is exactly matching the profile of my wing. No surprise here. And the other one here is another profile of 9%. So you start to guess that we are shaping a block, and this block is a stack to fit and achieve what we want. But do you remember that we have a damned problem, because here I have 2 of a 10 millimeters, and that's not enough. So I need to, what to do? I need to modify not my stack, but the true profiles that are part of the stack. Okay, you will tell me, Guy, don't worry, go to XFL5 and just modify. Yeah, but it's not exactly gonna to work, because I will show you how OpenVSP is powerful and how you could shape everything like you want. Let's forget a while or damned stack form. I have made a little wing. You start to guess. This span was very short. The span is 18 millimeters. So you guess what I want. I have used the two profile I wanted for 9%. This is a middle section, and the outboard section is 7.5. You guess that I want to reshape these two profiles in a wing section. We say Guy, why you don't do this in the stack section? Because in the stack section, I don't have much control on the profile itself. I have more control about bodies. I have created a wing just to correct the profile. And so let's do it. Let's have a look on both profile. So if I am making symmetrical, you can see that it looks like my stack. If I put on this the fuselage to help you, sorry, I have many, you can see how it looks like. I can move this a little bit if you want. So you understand where I want to go. You could notice that at this exact moment, maybe you are happy with the result. Maybe it's enough for you. So you just have to keep this and go to the Analyze, Trimmed Surface Export menu to export in output in step or EJS file this body. That will probably be like a solid because it's closed. But I want more. I want more because I want to have more control of this. But first, we need to get back this .NET profile. So let me show you again. We have two sections because we only have two profiles. So let me show you how I can have control on these two profiles. For example, on the trailing edge, which is what I want, this is a normal profile, how it looks like when it was coming from the DAT file. And now let's say that I want to have more thickness right now, and I can choose. So you remember this. This is the value that I had in Fusion 360 by default. And now I have 1 millimeter. Yeah? But I'm not really happy with this because I would like something more aesthetical. I had something rounded. I have the control I want. I can ask in relative, 1% relative, but in fact, I prefer to control in absolute and use 1 millimeters, which is not the same than 1%. I can move the line up or down, which will be not the same. So I can also extrapolate, but the best is to do this, and I can make an offset, which sounds like crazy, but everything is possible if I would, but it makes no sense here. And I can increase the length of the edge, but it makes no sense also because during the milling, this type of curvature with a bit of 1 millimeters, it's not gonna to happen. So let's come back to 1 millimeters. So I will have a slight differences in length in the code of 0.5 millimeters, but that is nothing. So we want something malleable, and now we come back to the main profile highlighted in blue here, and you can see that I put 3 millimeters, but I could put 1 to show you. It will be like this. So let's 3, it's perfect. I have improved the length because of course I want at least 1.5, and I'm happy with this. It looks like fine for me. And now I need to get back this as that file to re-inject this into the stack bodies. How I could do such a thing? So first of all, we need to come back here. I want to show you. We have here an U number. So if I put 4, I will have several ribs. Right now, I will have 5 ribs. It's not what I want. I want only to have my original ribs, so I will put 2. I want to get back the profile in the central section and on the board. So let's suppress simply here this one, and now we have really 2 profiles. And now we're gonna to use the export menu, and we will click on the DAT. So you can see Selig Airfoil option. I think that Selig is a name that you know if you are really into glider. Selig has done many aerodynamical tests wind tunnel and published a lot of data about polars and so on, made a lot of experiments. Let the W test factor to 1. Normally I put, okay, test stack, video, and type accept. What is important is to remind that we have only one section with 2 profiles. I think you can see this right now. So the 1 is an outboard and the 0 is inboard, central. All time working like this in OpenVSP. Let's have a look in our files. I suppose that we have the 0 here, and I will rename this. This is Karman thickness 9 main for stack. And now it looks like okay. I just want to change this. It will be better for later. Yes, good enough. And here I have to rename this one also. And this one will be and this will be wing for stack. So what we want here is to come and on the extruder of the Karman we want to increase the height of a profile. I am gonna to show you right now how to do this. So you can notice that we are in the X section. We have the 0 section, which is the profile of the wing, because we need to have the profile of the Karman matching to the profile of the wing. And the 01 is a profile that is somewhere in the middle of the fuselage. I'm going to show you right now how it looks like. So it looks like this. I think that it shows pretty well how the stacks looks like, and you can see that it's open because it's just like a skin. If we come here, I come to the stack, I made a copy. You can see that the 01 is the outside, which is matching the wings profile, and the 1 is in the middle, somewhere in the middle. And we are interested, of course, to modify the one which is the middle, because it's the one who's gonna to have some effect on what we want. And to do this, we simply here edit curve. There is a way to do this very quickly. It's to modify the height of the profile, which means that we will change, let's say it was 9% or 10%, you want 12, let's say. So I will put here 22, and you will see the effect right now. You have seen this. It has increased the height of the middle section. But it has some counter effects, and I will show you this right now. So what happened is simply you can see that now the top of our Carman or stack is bumping into the fuselage, and of course we are not keen to keep this because we are messing our fuselage. I need to remove this 22. Yeah, and so it's really looks like better now. So we have to edit the curve, and we have this profile, and what we want, so you can see the effect of changing right now the dimension of the profile. So I access to this window, and I can't access to any points, and those points are here under. So you can have let's say 40, we have almost 45 couple of points. In fact, there is three points per references: Y, X, and Z. And Z we don't touch it, but we need to move the wire. This is the most important because the X is already fixed. We just need to change the wire axis. To make this more simple, I will click the selected point 1, 2, 3, and you can see it's moving around the profile by showing me the yellow square point, but unfortunately it's moving every 3, but it will help us to go there. Let's say that we want to start from there, and we're gonna to increase this wire. We will add 2 here. It's a lot. It's a lot. Yeah, you can see that's making a bump. I prefer to use numerical value rather than to play with the cursor in the graphic because I have more control. Yes. Don't be shy to put quite high value. So you see how it works right now. If I move my window, we can see here already the work. So how we can see the difference, I will just click on no show here and put the normal one. So you can see the difference here. Okay, we have significantly increased the height of the Carman along the fuselage, and that was exactly what we wanted. If I want to come back, you can guess that I'm not really satisfied with this part, and I should increase the height, which means that I need to come back to the curve, and I need to come back to, I suppose, this point. Seems to be this around here. I think that we are not so bad. Okay, let's try to know. It's better. it's really better. So I will make a view on the left to watch carefully, but I'm not totally convinced. I want a little more here and a little less here. Okay, so you have understood how it works. I hope that you have understood everything. I remind you that normally you can come here to play. This is the summary of the video. You can play here normally with all the cursor here, and if you are not happy with the cursor, you just input manually your value. Yeah, so you have a lot of slides. Each slide is about above, extrudo, bottom side, entrado, Karman, right side, and trailing edge, left side, leading edge. And just playing with this, normally you could achieve a very satisfactory result. First, if you are not happy with this, you just come to the X section and you will publish by editing the curve, and you will manually moving the point that you are interested in. And you will do this likely to have more control by just typing the value you want accordingly to the visual graphics that you have.